All right, so we are continuing on here. Today we're going to take a look at another very important data structure in Python. So Python, this is all in base Python. So far we've looked at lists, and today we will look at dictionaries. Dictionaries are a very important data structure in Python. A lot of things in Python are implemented using dictionaries. Dictionaries offer just some really nice features that, depending on the purpose that you are trying to accomplish, the thing that you're trying to accomplish, sometimes they're a lot more superior than lists. Obviously, they play different roles. But let's go ahead and take a look. So here I've opened up our today's notebook, and I'm going to kind of just run through them. So here, basically, you create dictionaries with curly braces. Okay, so on your keyboard you have a few kind of braces. You have square braces, you have curved braces or parentheses, and you have curly braces. So squared braces are used to create lists. Curly braces are used to create dictionaries. And then on Friday, we'll look at parentheses or curved braces to create tuples. But that's one way for you to be able to distinguish one data structure from another is by looking at what type of brace is being used. So dictionaries are created using curly braces, and everything in a dictionary is a key-value pair. So you have a key and you have a value. And the keys are mapped to the values with a colon. So if you just kind of want to manually create a dictionary, you'll put your key on one side, and then you'll do colon, the value, and then you separate these things with commas. Here, my keys are the strings Adam, Bob, and Carl, or the character strings there, and then the values here are, I'm just pretending that these are like their ages and years. Adam is 25, Bob is 19, Carl is 30, or something like that. And that's how you create a dictionary. We're going to assign the name. We're going to have the name point to the dictionary that we've created. And then if I ask, okay, what is this name people? Then it prints out the dictionary and it looks exactly like this, okay? If all of your keys are simple strings, and you have no spaces at all, you can also create a dictionary using the dictionary function, and you can do something like Adam equals 25, Bob equals 19, Carl equals 30, and this will produce the same thing, and it will automatically enclose each of the names that you specified in quotes. Now, technically, you can have a key where you have a space or something, but you would not be able to use this dictionary function. Whereas, up here, I could do something like this, and that's okay. I can put Adam at AD space AM here, and that would work. If I try to do it here, this says you're not allowed to do something like that, okay? So anyway, let me go back and fix this, because I don't actually want that. All right. So that's if you're like manually typing in stuff to create a dictionary, which is fine, which is a totally common way people create dictionaries. But perhaps you have other kind of things, other data structures created, and you can create dictionaries out of these other data structures. So for example, let's say in some other part of your program, you have created lists, and you want to, you have a list of keys and you have a list of values. And you can create a dictionary by zipping the lists together, okay? And so in Python, there's a function called zip, okay? And zip will create a zip object. So here I have a list with the name Adam, Bob, Carl, with the strings Adam, Bob, and Carl as elements of the list. It's a list of length 3. And then here I have a list with the integers 25, 19, and 30, also a list of length 3. To create a zip that you need to have 2 iterables of the same length, and I'm going to zip them together. Now when you zip them together, Python creates a zip object. And what this means is that Python is what we consider lazy, in that it does not do something until it needs to do it. So here we're saying zip these things together, and Python creates this basically like instructions that says, okay, I will do what you're asking me to do, but I don't want to like trouble your computer with all of this computation right now, right? So you could imagine having a list of length, 1,000, two lists of length 1,000, and Python's not going to bother like zipping all of those things together. It's only going to do it when you say, hey, I actually need these things now. And so here I'm going to say, hey, create this zip object, and then I'm going to put the zip object inside this dictionary function. And then Python says, okay, now you actually want me to do this, and then it will do it. Okay, and so here it's going to zip the name or the key with the value. So it creates a dictionary just like everything else. Okay, and a zip basically just kind of much like having a zipper on your jacket. It kind of just interleaves or interweaves an object from this side, an object or a value from that side, value from this side, value from that side, value from this side, right? And so you have these two things, and it kind of matches them up and does it. But again, if you just say zip, you get this zip thing and a memory location, which is just kind of this these instructions that says this is to be done, okay? And it only actually does it when you want it to, and that actually saves memory and speeds up the operation of Python, because it's not going to actually do things until it actually needs to do it. Because sometimes you create these things and you don't actually use, like you might have these 2 zip objects where like you need, you have like 1 million of these things that are going to get zipped together, but perhaps you only need the first 100, okay? So why bother doing the other 999,000 of these things if you only need the first 100, okay? Just kind of like saying like, hey, do the Taylor expansion for, I don't know, some function, right? And for a lot of these things, they're infinitely long, and we don't actually need the full sequence. We just maybe only want the first 5 elements or something like that. So it's just kind of like, okay, here are the instructions, but I don't actually need every single element, and that's kind of how Python does a lot of these things. So same thing with a lot of kind of other functions in Python. Yeah, question.
So could you use the curly braces here as well?
I don't think so. Let me just double check. So in this case, I don't think you can do curly brace zip, but I'll just double check. Yeah. So here you get a curly brace, and then it just puts in the zip object itself. So here you would need to call dictionary onto this thing to do it. Okay. Okay, another way to create a dictionary is here I have a list, and inside the list I have these key value pairs. Currently they are tuples, but they could also be lists of lists, I believe. And here I say, make a dictionary out of it, and it joins this, right? So here, and I'm pretty sure I can do, replace this with a dictionary, and it will do it. So here, I have tuples or lists, and I think that's fine. And I think I can also replace this iterable with a tuple, and it creates all of these things are just fine. So in our case, whether it's a tuple or whether it's a list, inside here I have these, these key value pairs here, and it creates a dictionary. Whereas if I take the insides and I put it inside a curly brace here, I don't think this will work. Yeah, it says, okay, oh well, here I get an unhashable type, but basically it does not like this. Okay, so if you want to kind of take a different structure and turn a dictionary out of it, you call the dictionary function. But the curly braces are great for like if you are going to kind of enter the key value pairs yourself in the format that a dictionary expects it to be. All right, so once you have the dictionary created, so again here my dictionary is the keys are Adam, Bob, and Carl, and the values are 25, 19, and 30. You can then access any of the values using square brackets. Okay, so here I'm going to say people square bracket Bob, so it's going to access the value associated with the key Bob, and it comes back and it says, okay, the value associated with the key Bob is 19. There's also a function called get. So people's a dictionary, and you can take whatever your dictionary is called, and you do a dot get, okay, and you get the value associated with that key. All right. The difference between using the square bracket and using get is that if you try to look up something that doesn't exist, okay, over here, this comes back and gives you an error. So if you say, people, give me the, what is the value associated with the key Joe, it gives you an error. Here, if you say people.getJoe, okay, and it doesn't find the key, it's going to return none. So here, because I asked for print, it prints out none. Otherwise, if you just do like people.getJoe, when it returns none, it looks like nothing has happened, right? So it's returning none, so it looks like nothing has happened, but it's actually returning the none value. It's just by default, Python doesn't display anything when it returns none. So here, if you call print that none, then it prints out none here. Okay. If you want it to actually return some kind of value, if it doesn't find it, you can use people.get, and then you put in the key name, and then you put in say the null value here, integer 0 here, and then here. Let me also just kind of we'll do Adam. Okay, and so you can also have a variable, right, where you can get this, and this also works. Okay, so you can have a variable that contains what do you call it? A key name, the name of the key, or the value of the key, and then you can call get, and then you put in J, or you do people square bracket J, and it retrieves those values. So it's getting the value associated with that particular key. Okay. Keys in a dictionary has to be what we call an immutable object. So you can use strings. So again, strings are immutable. You can't take a string and say change the third letter in a string. All right, you have to create a new string or something, right? So anything that's immutable can be used as a key. So you have strings, numbers are immutable, so whether those are integers or floats. Tuples are immutable, and functions are also immutable. And so those things are all can be used as keys. As far as what can be a value, there's no restrictions on what can be a value. So values can be lists, values can be functions, values can be other dictionaries, tuples, whatever it is. So here is just, this is not a great, this is just very silly. Here I'm using the keys are 1, 3, 4, and 2, and the values are the length, function length. The value for key 3 is this dictionary. This is a tuple, this is a list, and we can retrieve any of these things, right? So we can say, hey, what is the value associated with each of these keys, and we get that. Okay. What we mean by immutable, another way of immutable is these are objects that we consider hashable, okay? And so one thing that cannot be used as a key would be a list. A list is a mutable object because what we can do is we can take a object in memory. So if you can take the object in memory and then change things about that object, then that is a mutable thing. So remember, with a list, we could say, all right, create this list, and I want to change the first element in that list to a different thing, right? I want to append something to that list. So that object itself in memory will change. Versus a string, if you create a string in memory and you have a name pointing to it, and let's say you want to change the value of the string, you can't just say change the first letter in the string or change the third letter in the string or something. You have to define an entirely new string, right? So if your string is ABC and you want it to become ABCD, you can't just say take ABC and add the letter D, right? When you do that operation, ABC plus D, that does not modify the original string ABC. It creates an entirely new string called ABCD. So those are strings are immutable. Versus the list, you can have a list containing A list containing B, containing C, and then you can do list.append. List.append will change that actual object itself and modify it, right? And list.append is different from doing list ABC plus list D and doing that, because that creates an entirely new list, right? So even though the results look the same, a list containing ABCD, the .append modifies the list and actually changes that actual object, versus ABC plus D creates a new list containing ABCD, right? And so similarly, but anyway, all to say, because lists are mutable, that they can be altered, they are not allowed to be keys. One thing about dictionary keys is that those objects cannot be changed. So here I've created a list. I'm going to call it L, and it's a list containing the values 1, 2. A tuple, and we are going to learn more about tuples on Friday. A tuple is like a list, but it's immutable. You cannot take a tuple and append things to it. You cannot take a tuple and change the first value to something else. If you want to modify a tuple or something, you have to create an entirely new tuple. So you can take this tuple containing 1, 2, and you can take another value 3 and create an entirely new tuple that contains 1, 2, and 3, but you can't take this currently existing tuple and change it. So we have that. Here is a dictionary, an empty dictionary, just empty curly braces. And one thing you can do is you can just take, you can do D square bracket, and you can put in a new key that doesn't exist and assign something to it. So here I'm going to try to create a new key using this list, and I'm going to try to assign the value won't work to it. And when I try to do this, this gives me an error. It says the list is an unhashable type, okay? Basically meaning the list, things that are mutable cannot be hashed. Hashed is kind of the idea of there's something called a hash function, and it's going to kind of create like this unique, not really unique, but it's going to create like almost like a fingerprint-ish thing. So like, when you go and git, one way it knows that files have changed is that it basically takes the hash of the thing and it produces a thing, and anytime a file changes, the corresponding hash also changes, and that's how it knows the file has changed. Okay. There are things as hash collisions, so it's like you can have two different files that produce the same hash, but basically you have one file and it produces a hash, and if just one bit in that file changes, it's going to produce an entirely new hash. And so sometimes if you're on the internet and you're like going to try to download a file, you'll see that it'll say here's the file and here's the corresponding hash, and that's a way for you to check if the file that you downloaded is the exact file that you're supposed to download, because you can run that file through a hash program, and it will produce the hash. And if those hashes match, then you know that your file is exactly what it's supposed to be. Because sometimes on the internet, things get garbled when you download things, and you download something and it's like corrupted and you can't open it. That would be an indication that something happened. But anyway, okay. So you try to assign assign a value to the key where you're using a list as a key, and that's not going to work. But here I can use the tuple as a key, and again, I started off with an empty dictionary. So if I just say, hey, what is D? Right now, D is an empty dictionary. And here I'm going to take this tuple and assign the value this is okay to it. And now if I ask what is D, I have a dictionary with one item in it. The dictionary object, or the key here, is this tuple 1, 2, and I can retrieve it. And then if I want to, get that back, I can ask D, what is the value associated with this? And it says that's going to work. And if I try to put in anything else, okay, I get an error, and it says this key doesn't exist, right? A key error. And you might wonder, like, why would I ever want to use tuples as a key? I can think of examples, and I can show you some. Okay. Okay. Oh, let me give you your first view quiz answer. Today's first view quiz answer is the letter D. D as in dog. So what do we do? Oh. So answer 1 is D. Okay. One thing about dictionaries, you are not allowed to have duplicate keys. Okay, you cannot have duplicate. If you try to create a dictionary where you're using the same key multiple times, it's kind of like it reads it left to right, and basically anytime it sees the same key and a new value to it, that new value just overwrites the old value. So here it's going to get basically the last values used here. So it's going to start off and it's going to do A is 1, B is 10, and then it rewrites. It changes the value associated with A to 2, changes the value associated with B to 0, and then it changes the value associated with A to 3. So when I get this, I'm going to just have A is 3 and B is 0 when you do that, okay? So if I ask what's B, what's A, we get 0 and 3. Dictionaries are not indexed by position. So with a list, you can say, hey, give me the element in index position 0. Give me the element in index position 7, or whatever it is. Dictionaries, there's no doing that. You cannot say, hey, what is the element in index position 0? There is no index position. And so if you say something like, hey, give me people square bracket 0, what is this going to do? It's going to give me an error. It's going to say, hey, that key of 0 doesn't exist in the dictionary, right? And there's no way in a dictionary for you to reference things by its index position. And in fact, older versions of Python, dictionaries weren't even ordered, and if you modified a dictionary, it might accidentally modify the order of things in the dictionary. Now dictionaries are ordered and they preserve order, but older versions of Python dictionaries were not ordered. But there's still no way to kind of ask for what is something. You can kind of think of it as like in a bag, right? So in a bag, there's no order of your objects, right? If I say, hey, give me object number 5 in your backpack, that's like a confusing command, because it's like, what is the first object and what's the second object in my backpack? That doesn't quite make sense, right? If you have like a stack of papers and I say, hey, give me the 5th thing in the stack, that makes sense. That there's an order when you have a stack. But you have a backpack, 5th object in there. I don't know. Okay. Dictionaries, similarly, you cannot slice a dictionary because you can't get things by position. So if you say, hey, so here's my dictionary. I've got these 3 people, and you say, hey, I want going from 0 to 2. That's nothing. It doesn't work, right? It says, hey, you can't slice this, all right? And then if I try to do Adam through Carl or something, it says, stop trying to slice the dictionary. Okay. There are some commands, or sorry, not commands, operators. The in operator is a way to kind of check to see if a key is in your dictionary. Okay. And so you can do Adam in people. The in operator in a dictionary is lightning fast. It is very, very, very fast. Versus in a list, the in operator is slow. Okay, so I don't know what is happening underneath the hood, but when you say, like, if you have a really long list, like a list with a million elements in it, and you have a dictionary with a million elements in it, okay, and if you say, hey, is Joe in your list, okay, the way Python works is it starts at the beginning of the list and it checks through and it goes, is it, at index 0 do I have Joe, index 1, index 2, index 3, and it keeps going through and it goes sequentially and until it finds like a match for Joe, and if it does, then it's going to return true. Joe is in the list. With a dictionary, somehow, because of this hashable thing, it can check all of the keys like almost instantaneously. And I don't exactly know how it works, but I just know that the in operator for a dictionary is very, very fast. And so in this, this homework assignment where you're checking through this giant word list, right? So you download this words.txt, which has like, I don't know, thousands of words in it. What you'll want to do is you'll want to create a dictionary, and then you can use the in operator on the dictionary, and that will be much, much faster than if you tried to take the words list and make the text file and make a list out of those words. Okay, the in operator with the dictionary, very, very fast. Okay, if you want to check for a value, like 19 is 19 in people, again, it's only checking for keys, so this is going to come back and say false. If you want to check for values, you do people.values, okay? So I have this. The in operator uses different algorithms for lists and dictionaries. For lists, it searches the elements of the list in order. As the list gets longer, the search time gets longer in direct proportion, whereas dictionaries use a hash table, and the in operator takes about the same amount of time on whether it's a small or large hash table. And again, mechanically, I don't actually know what's happening. I just know operationally, the in operator on a dictionary is very, very fast. Okay, you can, so here's our dictionary, Adam, Bob, and Carl, and we can just create new entries just by kind of defining a new key and associating a new value with it. And we can also modify something, right? So I can take an existing key and I can modify it and I can just change the value associated with Adam there. Okay, and we get that. Okay, if you want to remove a key, you have that. Okay, and so here I can do delete people Carl, and that will delete that key from the thing. There is pop. Okay, pop requires a key. So unlike a list where if you don't put in an argument there, it just pops the last one off. Again, with a dictionary, it doesn't index things by position. So there is no like last thing. I mean, there is a last thing, but that's not how it behaves. So if you try to call pop without providing a key, it's gonna give you an error. So here I'm gonna say, pop key Adam, okay? And so it's gonna return, so here's our dictionary right now. Our dictionary at this moment in time is Adam 26, Bob 19, Derek 33. And so if we pop Adam, it's gonna return the value 26, and it removes that key value pair from the dictionary, and we're left with Bob and Derek in the dictionary. If you want to combine dictionaries, okay, you can use update. So here I have people A with Adam, Bob, Carl, people B, Dave, Earl, and Fred. I was just trying to pick alphabetical names or something. And so you can take people A and you do dot update people B, okay? And basically this will kind of extend the dictionary. Basically it's going to take all of these things, and if they're new keys, it's going to like add them, okay? And we get that. If you, here's people A, Adam, Bob, Carl, Dave, Earl, Fred. And if you have like another dictionary that has some of the same keys, here I'm going to do Fred 99, Gary 18 here. And when you do update, then it's going to change the value from 27 to 99 here. So when you do this, you're going to get people A. So now Fred is 99. And one thing about Python is that when lists or dictionaries get really long, if it can kind of print it horizontally within a certain number of characters, it will. But then once it goes past a certain point, then it suddenly just prints it out vertically. But internally, these are the exact same thing. It's just the way it gets printed on the screen looks a little bit different. Let me just do a couple things. So here, if I do people A, and if I try to do people B plus people B, you can't do a plus operator, okay? So, a list, you could take kind of these two things and join them together with a plus, but with a dictionary, you can't. You're not allowed to do the plus, okay? So if you want to kind of extend one with the other, you use the update. We have things called view objects, and these are dynamic view objects. So here I'm going to just start off with, again, our very simple dictionary, just having the keys Adam, Bob, and Carl. And I'm going to create a view object called names. And I'm going to just take the keys within the dictionary. And then I'm going to create a view object called ages, and I'm going to create, and that's going to just be the values within the dictionary. Okay, so when you say like, what is this, right? So here, the names, it says dictionary keys, Adam, Bob, Carl, and ages are going to be dictionary, are going to be the values here. And so the way a view object works is that as the dictionary gets modified, so here I'm going to modify the dictionary by putting in a new key, ed, and associated with the value 40. Okay, so I've done this operator, and I have not redefined what names are, right? If I called, if I had made names to be a list of the keys, then it would have modified. But here the names object, names is a view object, and so we can see that without redefining what names is, it now contains the new key ed. Let me try to illustrate exactly the difference between, because this looks like a list, right? Names look like a list, and ages looks like a list, but these are view objects. Okay, so view objects, unlike a list, can't really be modified. They are just giving you a glimpse of what's inside the dictionary. So for example, it only supports a couple functions. So I could say, hey, what is the length of ages? And it's length 4, all right? Is 35 a value inside ages, this view object of the values? And that's going to come back and say false, right? So let me just show you a difference here, because again, this is a view object. It's showing us what is the contents of the dictionary values. So what I'm going to do is I'm going to take ages and I'm going to make a list out of it. Okay, so right now my view object says ages is the view object saying it's got the values 25, 19, 30, and 40. And then here I said make a list out of that, and so I have a list with 25, 19, 30, and 40. Not unusual here. I'm going to take the dictionary people and I'm going to add another value, another key value here. I'm going to create the key Frank, and I'm going to associate it with the value 29. So when I ask what is in ages, ages now gets updated containing the value 29. Whereas age underscore list hasn't been modified. This is just the list that we created earlier, 25, 19, 30, and 40. So the view object, the dictionary view object is a dynamic, and it updates as the dictionary gets updated. So here I could say, hey, what is the third element in ages, and that's that's one issue, is that you can't you can't get it. Okay, so you don't have an index 3. That's not one of those. So a view object, you can't say, hey, what is the third thing in there? Okay, and similarly, you can't, even though there is Bob in the dictionary, you can't get it here. Okay, so if you want the age associated with Bob, you should just call the dictionary here. Okay, but you can't do it with the view object. So again, view objects are handy, but they really only support a couple of functions. Okay, like length or the in operator. And then there's also another view object, which is people.items, which is basically like the dictionary itself, but it returns everything as tuples. So it gives you the tuples of key value pairs. Okay, and again, you can turn this into a list. Okay, but this thing is not dynamic, whereas dictionary items is a dynamic view object that updates as the dictionary updates. Okay, let me give you your second answer. Answer 2 is A. All right, so here we'll just create like a simple dictionary where we're going to use a dictionary as a collection of counters. So what I'm going to do, and then this is a little bit silly, but we'll just go along with it. Okay, so we're going to say, we have a string. And then we want to go through the string and we want to say, how many times does the letter A appear? How many times does the letter B appear in the string? How many times does the letter C appear? So on and so forth, okay? And, let's say if we wanted to do this, there's a few ways we could do this. One is we could create 26 variables, one for each letter of the alphabet, and then we could go through this string, kind of write a loop that traverses the string, and for each character, we increment the corresponding counter. So we start off with 0, and every time we see the letter A, we'll add a 1 to it. And we'll do that, okay? We could also create another list. Another way we could do it is we could create a list with 26 elements, and we could say, the first element, index position 0, corresponds to A, index position 1, the second element of the list corresponds to B, and so on and so forth. We could convert kind of each character to a number and use the number as an index into the list and kind of, again, increment the appropriate counter, so we can kind of go through that. Okay, and then one last thing we can also do is we can create a dictionary with characters as keys and counters as the corresponding value, and every time we see the character, we would add an item to the dictionary. And so one thing about this is here our dictionary is not necessarily length 26. So if our string only contains a few unique letters in it, our dictionary will only have a few unique entries in it. And so the first time it encounters something, then it will create that key value pair, and then after that, if it encounters the same key again or same letter again, it will increment it by 1. So here I'm going to start off. We're going to call this function histogram for I don't know. I guess we're going to count up how many times each character appears. So maybe histogram is not the right word, but I'm copying a function that someone else wrote, and they called it histogram. So here it is. So I start off with an empty dictionary, and called D, and we're going to return D at the end of this function running. And what we're going to do is we're going to iterate through the string. Okay, so for each character in the string, so string is an iterable, and we're going to go through every element in the thing. We're going to say if the character is not currently in the dictionary, right? So we got if the character is not in D, so it's going to check to see if the character is a key within D, and if it's not, then it's going to create a new entry with that a new key in the dictionary, and it's going to set it equal to 1, because this will be the first time it's encountered this character. Okay. Otherwise, it's going to find the entry there, and it's going to add 1 to it. So, very simple. And again, one thing, like Python, I think is like one of the easiest languages to read, just because it looks like you're just writing English here. So we write this, and then so I'm going to call it on this string abracadabra, and it's going to just go through A B R A C A and so on and so forth, and then the output, it says, okay, as it went through, it says I encountered A 5 times, I encountered B twice, R twice, C once, and D once. Okay, and that's that. So that's pretty cool. Once you have a dictionary, you can iterate over the dictionary itself. So when I can say for each key in H, okay, then so when you take H and iterate over it, it's going to iterate, the elements are going to be the keys, and we can say print out the key and print out the value associated with the key. So I'm basically going to just print out everything in the dictionary, but I'm iterating. So when you say for blank in H, it's going to go through the keys. So it doesn't see them as key value pairs or something. The default, Python, again, it retains the order of items in the order in which they were inserted. So as it goes through, it encounters A first, so that's the first element in our dictionary. Then it encounters a B, then it encounters an R, then it increments the A, it encounters a C for the first time, it increments the A, it encounters a D for the first time, increments the A, increments the B, increments the R, increments the A. And so the letters appear in this order. If you want the keys to be sorted in, say, alphabetical order or something like that, then you can call sorted, and it's going to sort the keys in some kind of order. And the same kind of sorting rules that apply to lists apply to dictionaries. So, you can sort strings, you can sort numbers, you can't sort numbers and strings at the same time, things like that, okay? So here it's going to sort the keys A, B, C, D, R, and so on and so forth. Here we can, the way a dictionary works and is intended to work is you look up the key and it returns the value. What if you wanted to do something opposite, where you have a dictionary where you have a key and a value, but now you want to look up a value and you want to find the associated key or something like that, okay? So this is not how a dictionary is supposed to work, because values are not required to be unique, but keys are required to be unique. So it is possible, you can imagine a dictionary, or here we have a dictionary where we have the value 2 is, B has the value 2 and R has the value 2. So if you do a reverse lookup and you say, hey, I want to look up 2, then what we would need to do is we would need to return both B and R or something like that. So we have to kind of iterate through this. So if you wanted to do this again, we would create a new dictionary, but it's a little bit weird. Okay, so so here we're gonna create a function called reverse lookup. Okay, and we're gonna start off with a dictionary, and we're gonna find we're gonna look up the value here. And it's going to iterate for each kind of key in the dictionary, and we're going to say if the dictionary has that key, or go through every element in the dictionary, look up the values, and if it does return that value, return the key. So what this will do is it will return the first element that it has that thing. So H is this, and going in the order here, if I say look up 2, it's going to return back the first thing. Okay. And if I say, hey, look up the number 4, it's going to say, hey, I couldn't find that, right, as it's going through this. So this is kind of, I would say this reverse lookup function is inadequate, because are, it's just going to go through it and it's going to just look for the number 2 in the values, and it just finds kind of the first element that contains the 2, which will be the B, and it returns that. But truly, there's actually multiple things that return a 2 right now. I use the statement raise. I used a statement raise, and this is how Python handles exceptions. And so basically errors. If it can't do something, it's going to return an error message. So basically, if the function encounters return, the function ends. And raise only exists if it goes through the entire for loop and doesn't return anything. Okay, then what is this function supposed to do? Right? If I didn't do anything, it would just return none. Right? So if it goes through the loop and it reaches the end of the loop, nothing happens. It didn't encounter that return statement. It would just return none. But what we want to do is we want to have it give some kind of error, and so we're going to say raise a lookup error. And so when I run this function reverse lookup here, it says, hey, we went through this and it produces this message: lookup error, value does not appear in the dictionary, which is exactly what I stated here, right? So so there are different kinds of error messages that you can do, right? So we've encountered errors, right? We have type error, so you can raise a type error. You can raise a back here, there should be a key error, okay? There are different kind of errors or different kind of exceptions that you can raise. So as you're writing functions and you want to kind of give information to the user about what they did wrong, you can do that, right? Okay, so here is if we wanted to truly kind of invert the dictionary, okay, then we can do this. So here I'm going to create a function called invert the dictionary. I'm going to start off with an empty dictionary, okay, and I could have just done double curly braces. But what we're going to do is we're going to iterate through the entire dictionary, and we're going to take, for each key in the dictionary, we're going to look up the value associated with the key, and then we're going to use those values and use those as keys in our inverted dictionary, right? So remember, what I want to do is right here I have A shows up 5 times, B shows up 2 times, R shows up 2 times. And what I want to do is I want to create an inverted dictionary where I say, hey, what is how many letters appear 2 times? And I wanted to say, hey, B appears twice and R appears twice. So we're going to go through, and it's going to start off and it's going to say A appears 5 times. And we're going to say, okay, is 5 a key in my inverse dictionary? And it's going to say, well, it's not. So let's create a key in our dictionary with 5. And right now, the value that's going to go in there, I'm going to put in a list, okay? And the list is going to contain the letter A, right? Then it goes to the next thing, and it says, okay, B appears twice. Is B is 2 in our dictionary? It's not. So it's going to create a new key with 2, and it's going to put in a list with B. And then when it encounters R, okay, in the original dictionary, it's going to say R appeared twice, okay? And then we say, all right, is 2 that value in a key within our dictionary? It is. So what do I want to do? I want to take the list that currently contains B, all right, and we want to append the letter R to it, okay? So here, okay, so here's my dictionary. I've got P, A, R, O, and T, and so I have a bunch of letters that had just appeared once. And so if I invert this, now we will see associated with 1, we have P, A, O, and T, and then associated with 2, R appears twice, right? And I can just kind of do this again, and we can do it with abracadabra. Okay, so that's that, and then I can say, hey, invert this dictionary, and then we will see, okay, 5, A appears 5 times, letters that appear twice are B and R, letters that appear once are C and D, and so on and so forth. So this would be a way for us to kind of truly invert the dictionary versus, this thing kind of works, but it only gives us the first element that contains like 2 characters or something. Okay, let me give you your last view quiz answer. Final view quiz answer is the letter B. Question 3 is B, and that will be it. We will go ahead and end here for today. Have a great rest of your day, and we will see you on Friday, and we'll look at tuples on Friday.